All right, so the next thing we're looking at here is how to balance a chemical equation. So what we just finished up the last time we were together is you were practicing writing out word equations, and then you were practicing writing out what I said was skeletal or skeleton chemical equations, okay? And it's referred to as skeleton chemical equations because we hadn't put any meat on them yet, all right? So the balancing of the chemical equations would be the meat part. So what you guys were doing was just putting the basis of, the chemical formulas down from what you took from the words. So taking those words, like say you had barium sulfate was one of the ones that you had. So you take your barium sulfate and you put it into a chemical formula, and there you go, right? Now, that would be step 1, right? This is step 2. So step 1 is, writing out your chemical formula from, taking the information from the names and the ions and whatnot. And so that would be referred to as a skeleton. Now we're going to put some meat on it. And this is where we come to balancing a chemical equation. All right, so we're going to start with just looking at this word equation here. Not even a word equation. So this is a scenario. We're going to write it all out as for a word equation. So when placed in water, there should be a comma here, I feel like. When placed in water, comma, potassium metal produces a solution of potassium hydroxide as well as hydrogen gas. All right, so let's write out the word equation for that. So we have potassium metal. You do not have to write metal, right? This is where you would have just put your little symbol, solid, so that we know that's solid. Plus water, liquid. We don't have to worry about the symbols right now for this one. And it's going to produce, so our products will be potassium hydroxide, okay, as well as hydrogen gas. And for this one, you can write hydrogen, you can write gas there, okay? Or you could put the G. And then potassium hydroxide would be a solution, so it produces a solution, so you'd have your liquid there. Okay, so that's your word equation, right? So we've done this, easy peasy. So now we have to write the skeletal equation, which is the chemical formula, right? So for potassium, you would just write your K, right? Plus water, so that's your H2O. And then it produces your potassium hydroxide. Some of you would have to look up hydroxide. It's a polyatomic. And this is where you would check your ions to find out, how many charges. So there's a +1 for potassium. Hydroxide is a -1, right? So potassium is giving up an electron. Hydroxide only needs 1 electron. So only needs 1 for 1, right? So then we could just do like so. And then hydrogen gas. Remember, hydrogen is one of those diatomic elements, never found by itself, right? So it's going to be H2. All right, so now count the numbers of atoms on each type in the reactants and the products. Okay, so rewind, remember, reactants, products. Okay, so reactants, we have potassium, there's 1. Okay, this is where the counting of the atoms comes into play, right? We also have oxygen, there's only 1. And we also have hydrogen, which is 2. And on the side we have potassium, which is 1. Oh, I knew this was going to happen. Products, we have oxygen, 1. There's only 1 there. Hydrogen, oh, I'm going to have to get another pencil. Okay, got another pencil. All right, sorry. So hydrogen, there's 1 here and there's 2. So together, there's 3. Are they balanced? No. Okay? So, this is where the balancing of the equations come. Okay, so remember we talked about law of conservation of mass, right? So whatever you start with in a reaction, you have to end with. Atoms cannot be destroyed, nor can they be created. Okay? So whatever you start with, you have to finish with. Sorry, that's my dog walking around. So that's why we have to balance these equations, because you have to make sure that the same number of atoms is on both sides. So what I'm going to do is I'm going to rewrite down here our chemical formula. So it's K. Oh my goodness, these pencils are terrible. Plus H2O. And it's going to produce, our products are going to be up potassium hydroxide plus hydrogen gas, okay? We need to make these equal, okay? So, a few things here, okay? And yours, I think, is all filled out down here, but I'll go through it. Is you cannot change any of the subscripts, right? So these numbers down here, right now, these ones don't have any, but they would all be 1. This one has 2. This one has a 2. You cannot change those. You cannot put a subscript in, okay? The only thing that you can do to this is to add coefficients. And in these brackets, that's the large numbers out in front, okay? You cannot change anything else, okay? So what we're going to do is we're looking here. We have 2 hydrogen, 1 hydrogen. We have 2 hydrogen here, right? That's the one thing up here that's different. So what are we going to do? We need to make those the same, right? But whatever you add, when you add a coefficient in front, this is, remember, go back to counting those atoms, that number in front is multiplying everything else, okay? So if we put a number in front of here, even if you put a 1 there, then you're just going to go 1 times 2, so that doesn't change anything. Side note, for that, you would never put a 0 in front, because then that takes the whole thing out of the equation, okay? So if it's blank, there is a 1 there, okay? So there is at least one of these. It's in the equation, okay? So you don't have to write a 1. Again, this is where those scientists get lazy. They won't write 1s there. If it's blank, it's just that would be 1, okay? So what we can do is we can then put a 2 here. All right? So then that gives us 4 hydrogen. So we go up here, cross this out, and now we have 4 hydrogen on this side. Okay? That also changes the oxygen, though. So now we have 4 oxygen. Okay? Now, this isn't balanced yet, right? Because we have 4 here, we have 3 here. This is already 2. What can we put in front of here to make this hydrogen 2? Well, we could put a 2 here. Okay, so now we have 2 here, 2 hydrogen here, 2 here, and we have 4 now. But then this also has changed the potassium. Oh my goodness, these pencils. And it also changed the oxygen. Okay, but now the oxygens are balanced because there's 2 on this side and 2 on that side. There's 4 on this side, 4 on this side. All we have to do now is balance out the potassium. We could put a 2 here, and that gives us 2 potassium and 2 potassium on the other side. So now it's balanced, and there's nothing here. So you can leave it blank if you must. You can put a 1 here just to feel like you have it finished and complete, okay? But even if it's blank, it's still a 1, all right? Because this is part of the equation. You can't put a 0 there, because then you always have at least one of these, whatever, in the equation, because it's part of the equation. Okay? All right, so hints for balancing equations. I'm going to write it in pen right now because the pencils are irritating me. So hints for balancing these equations, okay? Big thing, make sure all formulas are correct. And the big one that I've noticed in some of the work that I've been watching and taking up is including the diatomic elements. Remember? Diatomic, the 7-Up rule. Those gases, they cannot be, they're always in pairs, right? So your oxygen would always be, O2. Nitrogen gas, N2. Hydrogen gas, H2, right? They're always found in pairs, okay? So in making sure those are correct, those are going to have a big effect on whether or not you're going to be able to balance your equation after you've written it out. Balance the metals first. Balance metals. Metal atoms. I think you have written that though. Balance metal atoms first. Okay, because they're usually in one spot. All right, and as you go forward, so for example here, so potassium, that's our metal, right? There's only one spot on each side, so those are kind of easy to get balanced. Whereas things that you should wait till the end to do, hydrogen, oxygen, because they're usually more than one spot. In this case, hydrogen in 2 spots. Okay. Those will be hydrogen, oxygen. Those tend to be in more than one spot. So those are the ones you want to wait till the end. And for the most part, a lot of the time, they end up balancing as you work on the other ones instead. Like when you work on the other, like the metals first, you get those done. It tends to make the rest of it easier. Balance polyatomics as a group. You can't split them, right? So your sulfate, your nitrate, it's a whole, okay? You can't stick a subscript in there and change it. Okay, so I already mentioned this. We're going to say the balanced atoms that occur more than once. Balanced atoms, which occur. Oh, I am having one of those days. Which occur in more than one place. More than one, let's say, molecule. More than one molecule last. And this is usually, what I just said, was your hydrogen and oxygen tend to be in more than one spot. Okay? Okay, and then the 5th one is that Low's terms rule, right? So I'm going to give you an example of that. If every coefficient, I'm forgetting how to spell right now, will reduce, rewrite in the simplest, I'm sorry, my handwriting's terrible, whole number ratio, right? So, for example, if we had 4H2O plus 4 potassium equals 4 potassium hydroxide plus 2 hydrogen gas, we can reduce those 4s, right? And that 2, and then it could just be 2, 2, 2, 1, which is what we had at the top, right? Which is up here, 2, 2, 2, 1, okay? So if you end up balancing and it looks like this, I expect you to be able to reduce those. So it'd be 2, 2, 2, 1, okay? And then remember your diatomic. So you have a practice sheet that you're going to do, but I'm going to just do a couple here. This is not the practice sheet you have, but you can look at it. If you want to write a couple down, press pause while I go through it. That's fine. I just want to go through a couple just to show you how I do it. Some people will do like a little check here, left side, right side, and list the elements, right? H and N, H and N, right? So on this side, there's 2, there's 2, there's 3, there's 1, okay? So something I always look for, and in this case, I always try, you gotta make it even, right? So because this is a 3 here, and there's a 2 on the other side, I know that the only way that those are going to balance is if they're both even numbers. I got to get this one to be an even number, right? Because it's a multiply. When you put the coefficient down, you're multiplying everything after it. There's not adding. You're not going to put a 1 here, and all of a sudden now you have 3 hydrogen. Okay, if you put a 2 here, it's two of these. You have 2 hydrogen gas molecules, which means you have 4 hydrogen altogether. Okay, so you got to make them even. So in this case, that's the first thing I'm going to do. Whether it's going to work or not, I'm going to try it. I'm going to throw a 2 down. Okay, so now all of a sudden I have 2 nitrogens, okay, and I have 6 hydrogen. Okay, so my nitrogen, perfect, it's great. My hydrogen is not. So what I'm going to go over here and I'm going to throw 3 there, so that makes it 6. Right, 3 times 2 is 6. And now it's balanced. Okay, so that's how you're going to look at it. So then you go down here and I see, oh, this is an odd number. I already know I want to do something about that. Okay. So only the first step I can do here is throw a 2 there to make it even. Now I have P. If you want to do that this way, I don't usually do this now. This is how I started learning, but now I've practiced these enough now that I can do it in my head. But if you want to do left side, right side, that's fine. So I've thrown a 2 there. Now I have 10 oxygen, and I have 4. We have 4 phosphorus on this side, and then we have 2. So we're going to throw in front of there. We throw 5 to make that 10. Okay. I'm just looking down here. Okay, I'm not going to do them all because you're going to go and practice yourself, and you're going to do the gizmo too to practice. So what I'm going to do is I'm going to, I'm looking at these and I'm like, how long would it take me to do this? But let's do this. Let's do this. So I wouldn't do a left side, right side for this. But one thing, remember, this you use these are units, right? Like, I'm going to, you use those as molecules. You don't, they're your polyatomics, right? So you balance them as a polyatomic altogether. Anyways, sorry. Okay, so what I would look at here is, we have, so one ammonium, okay? And then we have our phosphate, one of each. There's actually 3 ammonium here, right? And then we have a hydroxide and hydrogen, which obviously they came together to make water on this side. So, I'm not looking at the polyatomics right now. I'm looking at just the hydrogens and the oxygens. And usually if you do that, it all ends up balancing together. So what I'm seeing here is, wait, so as of right now, they are balanced. No, they're not, because the hydrogens are not balanced. So what I'm going to do is I'm going to balance the hydrogens, because we have 3 here, we have 1 there, so we have 4 on this side. So to start, I'm going to do, I already know that I can't. No, I was going to say I was going to do 2 here to balance the hydrogens. Now are 4 and 4, but that gives me 2 oxygen, and I can't do 2 here to make that oxygen 2 because there's 3 of those, right? There's 3 ammonium, so I have to start with putting the 3 there. So now those are the same, okay? So now I have 3 hydrogen here, 3 hydrogen here, so that's 6. And I have 3 oxygen. Oh, that just worked out really perfectly. And sometimes it does. Put a 3 there. I now have 3 oxygen, and I have 6 hydrogen. And everything else, the 1, is balanced. Perfect. That one wasn't as hard as I thought. Okay, let's do this one. So already looking at it, I looked at it, as soon as I looked at it, I'm like, oh, there's 2 potassium and only 1 potassium. So let's throw 2 here. That's how, you can start just like that, looking at the metals, okay? So there's 2 potassium, there's 2 chloride. There's 2 chloride, so now the chlorines are balanced, potassiums are balanced. Barium is 1, sulfate's 1, sulfate's 1, and the chlorine was 2, and so that one's easy too, done. And those are all 1s. Okay, let's do this one. This is a 2 and a 3, right? So automatically you'd want to just throw 2 here, and now the aluminums are balanced, but I already see that I can't do that because it's an odd number of oxygen, and this is an even number too. So I know I have to get the oxygens figured out. So if I do that, then there's 6, but now there's 4 aluminum, so you have to put 4 there. And then there's 4 aluminum, 4 aluminum. Okay, so we're going to stop there. You're going to practice. You're going to do the gizmo. The gizmo might help you be able to do it and have no fret, no fear, but the thing is with this is people either get it right away or they, sometimes, I don't want to say this meanly, but sometimes they never get it. And it's okay. It's okay if you don't get this right away. Because it really does come down to practice, and we don't have a ton of time to practice. So if you don't get it, don't sweat yourself. It's fine. It's fine because we don't have a lot of time to go through it. But I do want to go through the next thing. So while I pull out my sheet that we're going to go over, which you guys have already gone over. Or no, you haven't gone over it, but I put it into your note, is the types of reactions, okay? Okay, I'm actually going to put this on a new video, so then you can take a break.